So far in Chapter 11 and Unit 10, you have studied how to find the area of quadrilaterals and triangles. So now we are going to find out how to find the area of a regular polygon. So let's revisit what this word regular means. Okay, because that's the key to finding this area, or making it a little bit easier for yourself. So if we're looking at this regular hexagon, in question number 1, it says, given a regular hexagon with the length of AB equaling 10, we need to find the length of OH. So the word regular implies two things. Number 1 is that every single angle is the same measure. So all of these vertex angles are the same measure. And that every single side is the same length. Right? So it's hard for me to mark AB is the same length of AF, FE, etc. So let's just know that this AB is also the same length as all those others. So it says that AB is equal to 10. Well, let's go through some other definitions here. O is the center of this regular polygon here, regular hexagon. And if I draw a segment from the center out to a vertex, this is called a radius. Okay, you might be asking yourself, why is this called a radius? Well, technically, this is a regular hexagon because it's inscribed inside a circle. So every single one of these, right, we can go from the center out to letter D, from the center out to letter C, from the center out to letter F, and these are all going to be radiuses. That means they're all congruent in length. Well, if it's a hexagon, then what else is important here? So we know this is a radius right here. And then our next important vocabulary word is this, the definition from the center to the midpoint of a regular polygon. So this is going to be the midpoint. How do I know it's the midpoint? Well, if these are radiuses right here, those are the same length. So in other words, I have an isosceles triangle. And if I draw an altitude, because I see this 90-degree angle right here, then I know that I have bisected segment AB, which means segment AH is 5 and segment HB is 5. So again, these radiuses coming out to every vertex are creating isosceles triangles. Now, let's go and do something else that's important. Here, we have 1 angle, 2 angles, 3 angles, 4 angles, 5 angles, 6 angles, 5 meaning between the two radiuses right here. So 6 angles, 6 central angles. So that's another definition. This is called a central angle. Why is it called a central angle? Well, it's going back to the circle, right? Right here, these two radiuses. This is the arc, this is the central angle. There's 6 central angles in there. Therefore, what is the measure of each central angle? Well, remember we learned that all the way around the circle is 360 degrees. There are 6 central angles in there, so 360 divided by 6 gives us a 60-degree angle. Now, if this is a 60-degree angle up here, and both of these radiuses are congruent to each other, therefore creating an isosceles triangle, it's even more specific type of triangle in that if this is 60 up here, both of these have to be 60, so I've created an equilateral triangle. So each of these triangles in this regular hexagon are equilateral. So I have 6 equilateral triangles. Now, how is this helping me answer this first question? Well, again, I have to find the length of this red segment. How do I do that with only a length of 5? Well, I either need another length or I need an angle. Well, I just calculated these central angles and said they're 60 degrees. If I have an altitude that's going to bisect it, this is going to be a 30-degree angle, or I know this is an equilateral triangle, so this is 60, so I have a 30, 60, 90-degree triangle. Let's redraw that over here. So this is letter A, this is letter H, this is center O. This is a 60-degree angle, this is a 30-degree angle, this is 5. Well, if 5 is opposite to 30 degrees, then what is going to be opposite the 60 degrees? And hopefully you remember that 30, 60, 90-degree relationship, and you're just saying that's 5 root 3. So OH as an exact value is 5 root 3. If you happen to use the Pythagorean theorem, then you would get a decimal answer perhaps. Because you might say to yourself, okay, well this is an equilateral triangle, which means that AO should have the same length as AB, and AB was 10, therefore AO must be 10. So then you could say 5 squared plus OH squared equals 10 squared. So I do OH squared equals 100 minus 25, which is 75. I take the square root of both sides. I would get a decimal potentially, unless you have a TI Inspire, then you would get 5 root 3. Otherwise, you could also get 8.66. So both of these answers are correct or acceptable. Exact value right here, and then this is the approximate decimal. Okay, so that's step number 1. OH is 5 root 3. Now it says to calculate the area of triangle AOB. Well, again, if I draw a picture over here, because I've really kind of mucked up that diagram, I have A, I have O, and I have B. How do we find the area of a triangle? Well, that's base times height divided by 2. My base is 10, according to this given information. My height is 5 root 3, or 8.66, according to what we found up here. So that's 10 times 5 root 3 divided by 2. And that's going to give you 25 root 3. So that's my area as an exact value. But again, if you use your calculator and you get a decimal answer, you might have also gotten as an approximation 43.30. So either of these answers are acceptable. Okay, well, now that is going to lead me to how to calculate the area of the whole entire hexagon. Okay, now it should kind of be easier to see how we're going to calculate the area of the hexagon. What did we do? First, we had to find the height of one of the triangles in order to find the area of one of the triangles. And then you say to yourself, well, how many of those exact triangles do you have in this regular hexagon? And hopefully you're saying to yourself, oh, I have 6. So you're either going to take the exact value and multiply it by 6 and get 150 root 3 as your exact answer, or you're going to take that 43.30 and you're going to multiply by 6 and you're going to get your approximate answer of 259.81. So 259.81 units squared is the approximate answer. You should get 150 root 3 is the exact value. Okay, well, another vocabulary word right here. OH is also known as the apothem. Okay, well, let's go back and look at OH. What is OH? Oh yeah, OH is the altitude right here. From the center out to this edge of the regular hexagon, but it's intersecting at 90 degrees, so it bisected it. So this is the altitude, but in this case it's known as an apothem. So that's called the apothem. So we have a formula in terms of the apothem in order to find the area of a regular polygon. So any regular polygon. So it says the area of a regular polygon is equal to half the product of the apothem and the perimeter. So where is that coming from? It's half the product of the apothem. Well, the apothem is this height right here, right? So that was this right here, the height. I mean, we're taking half of that. So a height divided by 2 times the perimeter. Well, in order to find one triangle, we just did the 10. That would be the base. But what's the perimeter of this? Well, that would be 6 times 10, which is 60. So they put this step together. They took the base all the way around the 6 sides, which is 60. Then they multiplied it by the height, which is the apothem, and divided by 2. So our process here is the same as this formula. So sometimes it'll be easier to use the formula. Sometimes you'll have to find one of these missing pieces and plug it into the formula in order to calculate the area. So it's 1/2 apothem times perimeter. Now we're going to use that in some problems in order to solve. Now a lot of times this first part of practice is just to try to recall what the central angles will be for regular polygons. So it says find the measure of each central angle for the figure as it is if it is inscribed in a circle. So if it is inscribed in a circle, that means it is regular, right? So if a square is inscribed in a circle, well, what you're doing then is here's my center, right? So my central angle, you have to go from the center to each vertex. So we have 4 angles in here. And if there are 4 angles, we do 360 divided by 4. So each central angle, right, each central angle is 90 degrees for a square. A regular hexagon, we just did that above. It's 360 divided by 6. So each central angle is 60 degrees. A regular octagon. Hopefully you're saying to yourself, well, that's 360 divided by, how many sides does an octagon have? It has 8. So that's a 45 degree central angle, right? So we're adding one more side here. So we would split all of these in half. So we have 45 degree angles. This red part would be an octagon. A regular dodecagon, that's a 12-sided figure. So 360 divided by 12. Those are 20 degree central angles. Okay, why are those going to be important? Well, those are going to be important because not all the time are we going to get this perfect 30, 60, 90 degree triangle. We might have a 20 degree angle up here, in which case you're going to have to use SOHCAHTOA. So it's always, not always, but sometimes it's going to come back to what you learned in your right triangle trig unit, which is SOHCAHTOA. So remember, you still might bring up Pythagorean theorem because we have right triangles. You might use SOHCAHTOA. You might use your 30, 60, 90, or 45, 40, 90 degree relationship if that's faster for you. So be prepared for that. Okay, now you might want to pause and try some of these on your own and see how you do, and then come back and check your answers with me momentarily. Good luck. Notice here it says leave answers in radical form or round to the nearest tenth. You can do to 2 decimal places is what we have been doing on the quizzes and tests. So you can keep with 2 decimal places or you can round to nearest tenth. Okay, so you can scan down and check the answers if you want. For number 1, I got an area of 72 radical 3 or about 124.71. Letter B, I got 60 for my area. Letter C was 64 root 3 or about, oh, that looks like it's missing a number. Sorry about that. Or 110. Somehow my 1 got erased there. 110.85. Letter D is 36 root 3 or 62.35. Letter E is exactly 50. And letter F is 30.41. So if you got those answers, you probably don't need to listen to the second video. If you didn't get those answers, you want to check them now. I will finish this video trying to explain 2A, and then I'll make another video explaining the rest. So 2A, we have a regular hexagon. Apothem is 6. So remember, a regular hexagon always breaks down to a 30, 60, 90 degree triangle, but this time 6 is opposite the 60 degree angle. So you can say x root 3 equals 6, this information right here. So how do you solve for x? You divide each side by root 3. So x equals 6 root 3. If you have a TI Nspire, it's going to spit out 2 root 3. But that's only half of it is 2 root 3. So I have to double it to get the entire side length. So that's 4 root 3. But then remember, there are 6 sides. So 4 root 3 needs to be multiplied by 6 to get the perimeter. So I get 24 root 3, then it's 1/2 times the apothem times the perimeter, which gives me 72 root 3, or about 124.71. Okay, watch the next video if you need to see how to do B, C, D, E, and F, or you can try to pause it and look at my work. But I will chat with you soon.